Thank you, everyone, for joining this session on cutting through the large language model hype. So we're living in exciting times. We're witnessing an explosion of innovation driven by large language models, particularly around software developers and development and testing. It seems like every week there is a new announcement or a fancy demo that everyone's excited about. But how much of this is really applicable and practical for test automation, and how much of it is just hype? In this session, I'll share with you some of the experience that Applitools has gained over the years building and using AI-powered test automation, and I'll also show you what it looks like when it really works. So let's start by talking about the current state of automation. As you know, in recent years, there's been exponential growth in the complexity and scale of software. Applications are becoming bigger and bigger. Organizations are building more and more of them. The user experience of these applications is becoming more complex, more dynamic, and more difficult to test than ever before. On the other hand, teams are asked to increase velocity, to release features to production faster, and also to do that with fewer resources. Now, what we see in the field, what we hear from our customers, and what we also see in independent market research is that the traditional approach to test automation simply doesn't scale. Test automation is often being flagged as the primary reason for productivity loss and velocity loss for teams, and also for overall driving up the cost of software development. So, given the fact that the traditional approach fails to allow teams to scale, the industry has responded in the last few years by shifting the responsibility of testing left. First, shifting it left to test earlier in the release cycle, but also shifting it left to the hands of application developers. And it's easy to understand why the industry has embraced this process. It makes sense that if developers run their tests earlier in the release cycle, they will find bugs earlier, and it will shorten the feedback loop and increase velocity. It makes sense that if developers are responsible for testing, they will build applications that are more testable and make it easier to manage test automation. It also makes sense that if the developers own testing and they actually run their tests before they are committing code that changes the application, they will fix anything that breaks before they introduce those changes, and the automation will always be green and never fail. And it also promotes the concept, the positive concept, that developers should build features that actually work. However, teams that have shifted left find that it's not sufficient to succeed with scaling, and it has its own problems. And the main reason for that it doesn't solve the problems, is that it doesn't really matter who owns the test code, whether it is the developer, whether it is the automation engineer, or whether it is a technical tester. At the end of the day, the bottleneck is the test code itself. By requiring the person who owns testing to be a developer, you are excluding everyone who is a non-developer, perhaps an excellent tester, from contributing to test automation. As you all know very well, the end-to-end test code, especially element locators, are extremely fragile. The application under test changes all the time, and it requires a huge amount of effort to maintain this test code. In many cases, more work than building the application itself. If the developers are busy working on that code constantly, they just don't have time to build the application under test, and velocity drops. And if indeed the application developers are those responsible for testing, then there is a conflict of priorities, right? They are primarily measured by the amount of features that they add to the product, and this is their main KPI, which means that whenever there is a lack of resources, which we all know is always the case, there is always not enough time and not enough resources to do what needs to do, testing will come secondary. And it will often be rushed, neglected, or sometimes not done at all. So given that shifting left by itself does not really solve the problem, A lot of teams now look at the new innovation around AI to see if it can help them scale their tests, their automated tests. Now, if we put aside a lot of the legacy tool vendors that have added a prompt to their product, and now they can check the AI box, the marketing AI box, the majority of innovation that we see is focused on generating test code, right? We have plenty of new tools. We have GitHub Copilot that provides developers with fancy auto-completion for their code and ability to write unit tests automatically. We have the new MCP servers for Selenium and Playwright that basically augment the capabilities of models to be able to drive a browser, to have direct access to the application under test, and therefore generate test code for us that is tailored to your specific application. We have LLM-powered IDEs like Cursor the developers use to generate code automatically using prompts. And we also have the generic models like ChatGPT, Claude, Gemini, and others that developers use to generate code. However, what we see both with customers and both in the demos that we see online and from our own experimentation of our own development teams in-house, using tools to generate test code, particularly end-to-end test code, only reinforces the coding bottleneck. These tools, while they work very nicely for unit testing, because the entire class that you want to test fits in the context of the context window of the model, it does not work so well when you're trying to generate end-to-end tests, because you cannot possibly compress the entire application under test into something that the model has an overall view of. You've probably seen amazing demos of LLMs generating test cases for you, and people writing blog posts about how they went to get coffee, came back, and 15 minutes later, they had an entire test suite written that would take them 2 weeks to write, which is very nice. No one actually went into the test code to show the quality of it, but I can tell you for sure that I haven't seen a single demo where an LLM updated existing test code, where it actually saw product changes and actually was able to correct test code and replace locators and deal with the frameworks and libraries and everything that you really have in a real project. Okay, it just doesn't work as well, to say the least. Another thing that we see that is easy for an LLM is to interact with the UI. It can very nicely find buttons to click, very nicely find text boxes and forms to fill. But what about assertions? LLMs struggle with assertions. They don't know when to add an assertion, and they don't know what to assert on. Okay, so and this is like 80% of the test code, right? It's not just clicking buttons. So it's not that these tools are not useful for test code generation. They are amazing. This is an amazing technology that we can definitely put to use in many ways. But the bottom line is that at the end of the day, you generate test code that you cannot blindly trust. And you need a developer or someone with developer skills to supervise it constantly, which only reinforces the coding bottlenecks and all the disadvantage of it that we've discussed before. So if the code itself is the bottleneck, why not skip it altogether? Why not use an agent, like I heard in the previous talk, that I would just give it a prompt and it will run the test for me without the code. Okay, we can take a model, provide it with an MCP server, and just give it a prompt to test something, and it can operate the browser on the fly and come up with the test steps. So I don't know if you ever tried doing that. I have. I have some questions to consider this very appealing option. First of all, do you really trust an AI to come up with test steps on the fly on every run? And every run it will do other things. It won't be consistent. Would you really trust it not to hallucinate and actually do what you asked it to do and not skip important steps in the test? Do you really think that it will catch a bug if it sees it, rather than working around the bug to fulfill the goal of the test, which is what it's trying to do? As someone who is in charge of quality, would you really accept having no way of debugging a failed test or fixing it? Would you really agree to wait 10 seconds between every step of the test because the LLM needs to think about what to do next? And a test suite that would take you minutes will now take hours, or a test suite that would take hours will now take a full day? And will you be willing to pay for thousands of tokens on every test run? So everyone can answer the questions by himself, but at least I hope that for most of you, the answer is a clear no way, okay? And we need to be honest here. As exciting as this technology is, we cannot really compromise on the fundamentals of test automation. Stability, determinism, and speed are not really optional in any way. They are essential to succeed with automation at scale. And LLMs as statistical models are just not reliable and consistent enough for us to trust them blindly. So if the traditional approach doesn't work, and shifting left has its own problems, and the new LLMs that come out generate code for us or try to run the test for us, introduce new types of problems, what is the path forward? So at least the way that we define an autonomous testing platform at Applitools, the practical definition is to use those new technologies to make automation at scale accessible effortlessly to all teams. And in order to do that, we would like a tool or a platform to be able to attain near complete test coverage, taking teams from below 20% of test automation coverage to 80% and more, allowing them to catch unexpected defects, just like testers do with exploratory testing. We would expect a platform like that to lower the required skill set, to lower it to a point where instead of requiring a tester to be a developer in order to succeed at scale, to only require that he knows how to test, okay? And we don't expect a tester to be an AI expert to succeed at scale. We want to drastically reduce the human involvement from complete involvement that is required today to a point where you only need to look at test results and you fill the gaps where the AI failed to do the work for us. And of course, we don't want to compromise on the fundamentals of test automation. We want our tests to execute reliably in a stable and trustworthy way, exactly like we expect tests, our coded tests, to run today. So, given these expectations and goals, I would like to show you Autonomous, which is Applitools' autonomous testing platform for website and web applications, soon supporting native mobile applications as well. Autonomous is today the most advanced test development environment in the industry. It is not a POC or a vision. It is a working tool, a working platform that is already giving value to dozens of enterprise teams. Now, first of all, Autonomous include everything that the team needs to succeed with test automation at scale out of the box. You don't need any external dependencies. It includes the devices and browsers that you need to run your tests on, and it also includes the scheduling infrastructure. Of course, it has APIs and integrations that allow you to integrate it with any DevOps workflow that you have, but if you don't have it, you can do everything you need with Autonomous as it is. If what you're trying to do is test a website, or test a multi-page web application, or test a content management system like of a product, all you need to do is provide Autonomous with the URL of your website. On every run, Autonomous will crawl your entire website, find all the pages that are there, and report any HTTP error that it finds. If a page doesn't load, timing out, crashing, inaccessible, not found, etc. Any page that Autonomous does find, it automatically renders it on any device, browser, operating system, and form factor that you want to test it on, and it performs a visual test of that page, meaning that you get complete coverage for that page, whether it is new content that is being pushed, whether it is a bug that is introduced, or a new feature that is out there, you will know about it. Nothing will slip by. Even if nothing changed in your code at all, and just the browser version updated, which introduced some incompatibility with your website, Autonomous will let you know about it. Now, the test suite itself is self-maintaining in the sense that if a new page is added to your website, it will automatically get covered in the test suite. And if a page is all of a sudden missing compared to a previous one, it will be highlighted as an issue. So basically, you just need to sit back, wait for test results and findings, and you don't need to even edit or maintain a single test. For anything that is beyond a website test like that, Autonomous allows you to author your tests in plain English, really unstructured plain English. It's not a keyword language or something like that. You can describe the test just like you would write them in a test case that should be performed by a human. As you can see here on the left-hand side, we have an area where we can write down the test steps in English. And on the right-hand side, we have an interactive browser that shows us the application under test. Everything I write down on the left-hand side gets immediately read and executed by our AI on the application under test, so we can see that what we are writing down is understood correctly and actually works. On the other hand, I can also just interact with my application under test on the right-hand side, and the test steps will be written for me on the left-hand side. So in this case, we have a contact us form, and I can just fill it out. I can add my name. I can enter my email. I can choose a contact reason. I can add a visual checkpoint and submit the form. Okay, and as you can see on the left-hand side, I have a test written in plain English. Now that the test is ready, I can rerun it, replay it to make sure that it works. I can set breakpoints on these English test steps, just like a developer can set breakpoints in his IDE. I can run the entire test, I can run the steps one by one, and I can also modify the steps in real time to make sure that the test really does what it's supposed to do. Now, this approach to authoring tests where you can write them in plain English and immediately see that what you are doing works has many, many advantages over traditional low-code tools. First of all, writing a test in plain English is the most natural way to write and describe it. It's the easiest way to understand and maintain it. As you can see, there are no element locators here at all. Okay, and first of all, it means that there is no code and there are no element locators. So it means that everyone that knows how to test now has the ability to contribute, add automated tests, and maintain them and understand what they are doing. The fact that you don't need to add element locators besides lowering the bar of what is the skill set that you need also means that the test is much more stable because it no longer depends specifically on how the application is implemented. As long as the descriptions which are based on user interactions and how the user sees the UI are still applied to our application, the test will work. Another important advantage of this approach is that one of the downsides of legacy record playback tools, as we know them for those of you who are experienced, is that if you are recording something and the recorder made a mistake, and it's inevitable that the recorder will make mistakes now and then because developers can choose to implement their application in just about any way that you can think of. If the recorder makes a mistake, you actually see with a legacy tool, you're basically stuck. You're trying to click something, it doesn't click, there's nothing you can do about it. With Autonomous, the output of the recording is plain English. So if it doesn't work, you can use the power of the English language to describe better what it is that you're trying to do. So even as a less technical tester, you have the ability to help the AI do what it is that you're trying to do. The last advantage of autonomous that I'll mention on this slide is the fact that it is 100% SaaS. It means that you don't need to install anything, no extension, no local recorder, and this means that you don't need to deal with installation and upgrades, you don't need to ask permissions from your security team or IT to install things, but it also eliminates the range of problems where something works for me locally, doesn't work for my friend because he has a different version of the recorder, or maybe he's running on a different network, or maybe I have some kind of state locally on my machine that causes the behavior to be slightly different than when it runs in the CI. With Autonomous, the embedded browser is a video feed into a browser running on our execution cloud, which means that everything that you can record and play back will work exactly the same for your peers and in the CI. A very important aspect of Autonomous that we touched upon before is the fact that executions by Autonomous are stable, deterministic, and fast, just like a programming language. The reason it is possible is because the source of truth of the test is really these textual descriptions. There is no code under the hood. There is no Playwright or Selenium that that the text just describes and really code runs. The AI is actually reading those line by line and executing, understanding and executing what it does. However, the model that we are using is a deterministic language model. It is not a large language model. It is not a statistical model, which means that it will always interpret your test steps exactly the same way, deterministically, and once you've saved the test and you saw how it's running, it will always run that way. So you can trust it just like you can trust a test that you've written in code. We do use LLMs heavily when authoring and maintaining tests, and I'll show you a lot of cool examples of how we do it. But it only happens when you are maintaining or authoring the test, when there is a human in the loop that can see the outputs of the LLM. However, when the test is running, no LLMs are involved. Now, this gives you basically the best of all worlds. First of all, there is no code and element locators. Okay, so we eliminate the coding bottleneck that we talked about before. We do use LLMs extensively and do all the fancy stuff that you would expect from an LLM in this new age to help you with authoring and maintenance. But when the tests run, it runs deterministically, like with the precision of a programming language. With Autonomous, you can do anything that a developer can do in his Playwright or Selenium test. You can, starting with adding textual assertions. So for example, I have my name here in the name field, and I can add assertions, textual assertions. So for example, verify that the text in the name field is capitalized. Of course, that is correct because Adam Carmi is capitalized. If I would try to assert that it is lowercase, it would fail because it is not. Similarly, I can easily parameterize tests, just like I can add arguments to a test and to functions in code. I can replace my name. Is it stuck? Let me see. Yep, I can replace my name with Adam Carmi with a name parameter in curly braces. I can also replace my email with a parameter, and then when I will try to run the test, I will be asked to provide arguments to these parameters. Okay, and then I can specify a different name and email, and the test will execute with those values. So I can reuse my tests that are written in the English language with different parameters. I can also attach a test to a data set, which is a tabular data file where columns represent parameter names and rows represent parameter values, and do data-driven testing. The test will run for each row in that data set. So I can get that coverage. I can also easily capture dynamic data from the UI itself and store in variables, so I can use it in subsequent test steps, just like I can do with code. So for example, after submitting our contact us form, we get to a confirmation page that shows us an ID that we can use to track our request. I can easily grab it and store it in a request ID variable, just using the English language in any way that I can think of describing it. For example, store the text to the right of your request as request ID. And that's enough for the AI to understand it, grab that text, and put it in a request ID variable. In addition to textual assertions, Autonomous also allows you to add visual assertions that are powered by visual AI, which is by far the most advanced computer vision technology in the industry. This is the same technology that we have in our EYES project that maybe you are more familiar with. It's a technology it's a large collection of computer vision algorithms that mimic the human vision with very high accuracy. It has been developed over a decade. We're still developing it with billions and billions of tests that were used to refine it and get it to the state of almost perfection where it is today. The way that visual checkpoints work is that when a visual checkpoint executes, Autonomous renders the page, the current state of the page on multiple devices, browsers, and form factors, grabs screenshots of that state of the application, and compares those screenshots with baseline images that define how the application is expected to look like at this point in the test. If there are no differences, the assertion passes. If on any of these browsers or devices there is a difference, the assertion would fail, and you can clearly see the failure. So, in this case, we have a Wikipedia page. On the left-hand side is the baseline image. On the right-hand side is the checkpoint image that we are validating. And there is a difference that is highlighted in pink at the bottom of the page. We can easily highlight it and zoom into it. And we can see that in this case, the hyperlink icon changed. Okay, now I didn't need to write a specific textual assertion on that icon to validate it. I just said, check the entire page. So you see the amount of coverage that we are getting here. But it's not just the coverage, it's also the ease of maintenance. In order to maintain the test, I don't need to go back to the test and fix the flow or anything like that, or change assertions. All I need to do is just decide whether to accept or reject this difference. If I accept, the new screenshot becomes the baseline image for subsequent test runs. If I reject, I just keep it as is, and I can report a bug from within the app. Visual assertions have many advantages over textual assertions. First of all, they provide you complete visual and functional coverage for the current state of the application. And this one assertion is equivalent to writing hundreds, if not thousands, of textual assertions that would give you the same coverage that, of course, you would never be able to write. But the fact that it gives you so much coverage means that you don't need to add all those assertions, okay, that you used to, which means that your test becomes 80% smaller. This is a staggering number. 80% less test steps or code to create when you are authoring a test, but more importantly, 80% less test steps to maintain for the entire lifetime of the test. And if you recall, when we talked about the strengths and weaknesses of large language models, and we mentioned that assertions is part of the weakness of those models, in this case, visual AI covers that exact part. You have very powerful assertions that are at your disposal that use AI, different AI, not one that relates to language models, but to computer vision, to cover your assertions and really boost your coverage with very little maintenance. Now, the visual AI technology is extremely mature and really helps you reduce the amount of maintenance that you need to perform. So in this example, actually, we are testing the Wikipedia page on multiple devices and browsers, the same page. So 15 different devices and browsers on desktop and mobile applications. You can see the different form factors of the same page, and they all have the same difference with the hyperlink. If I accept or reject any of these occurrences, the AI will automatically apply it all over my test suite. So I only needed to see this hyperlink change once, even if it occurred 1,000 times over my test suite. Approving it or rejecting it will happen once, and the same action will be applied by the AI automatically everywhere. So really ability to scale your coverage without really increasing the amount of test maintenance. Autonomous also allows you to easily incorporate API testing as part of your end-to-end flow. So you can use it to initiate HTTP requests with full control. It's very useful to perform custom authentication. You can use it to set up the state of a test before starting it, clean up at the end of the test, but most importantly, it allows you to validate the state of the backend during your test, especially if you don't have an option to do that through the UI. Autonomous is very flexible in how you can specify API calls. It could be plain English, it could be raw HTTP request, it could be curl syntax, but we also support a UI request editor that is very similar to Specman. So if I want to test that the contact us form that I have, I clicked it too early, sorry. If I want to make sure that the contact us form in our demo that I just submitted really sent the correct details and they were stored on the backend correctly, I can easily add an API step, choose the HTTP verb, set the URL of the endpoint, add a query param that uses the request ID variable that I've defined in this previous steps, and just add this API test. It failed with a 401 error because I didn't specify a security header, authentication header that is required. I can easily add it through the headers tab and update the step again and see, and now it runs and passes. Once it passed, I can easily see the step described in plain English. I can edit it directly. For example, I can say that the header should be secret, and in this case, its value would be masked forever for security purposes. And I have full access to the results, the response that came back from the server. I can see the status code, I can see the headers, cookies, the body of the response, and I can capture all these values. You can see we have the email and name of Moshe that we said before. I can capture these details and use in variables for subsequent API calls or for subsequent UI interactions. And I can also assert and verify that this is correct. So I can, with one click, create a complex assertion that validates the entire response object. I can just then paste it after the API request, and Autonomous will split it into multiple assertions that verify each of the properties of the object, the name, the email, contact reason, and everything that is there. You can see that it was also smart enough to understand that the email and name are parameters of the test, so the expected value that is used is the parameter and not the specific values that appeared in the response. Everything that you do with Autonomous is seamlessly assisted with an LLM, from fixing typos to normalizing test steps and cleaning them, to disambiguating them, and even realizing that we are calling an existing tests and making it easy for me to find the test and use it without coming up with the exact name of the test that I want to reuse. So for example, if I type clack, the your name field, and clack is a typo, instead of showing me an error, the AI automatically corrects it to click and lets me know that it has done that, so I'm not surprised. If I write a step in an obscured way, for example, I'm say below your name, click the field, the LLM will automatically correct it to start with an action, so the test will remain clear and readable for my team. Even if I write the test in a different language, okay, it will still make a best effort to translate it back to English. And if I try to run another test with my own words, wipe the form clean, the LLM will find the corresponding test, clean the contact us form, and run it for me. Okay, so making it very easy for me to find and reuse existing functionality that I already have in place. But you can do a lot more. For example, generate random data, generating data sets. Autonomous allows you to use plain English, unbounded plain English, to describe test data that you need. And you can generate with it anything from a simple scalar value, like a date, and up to complex records with intricate relationship between their properties. So for example, we have our contact us page, and I want to fill it with random names of famous 90s movie stars, okay? So I can just ask the LLM to do it. So I can say generate random test data for a famous 90s movie star and store it as name and email. And that would be enough for the LLM to generate a data set for us and come up with a random value from the data set and store it under the name variable and the email variable. So now typing name would get us Tom Hanks, and typing email would get us Tom Hanks' email as generated by the LLM. If I would rerun the test, on the next run, I get Keanu Reeves and so on and so forth. Okay, so very easy to generate test data, and you can actually put in whatever complex data that you would like to describe. But you can go beyond that and actually express your intent for autonomous, and the LLM will actually write the test steps for you. Okay, so if I want to fill the form, I can just specify that I want to do it. So I can say, fill the form as a famous 90s movie star. And the LLM will understand it, create details of a famous 90s movie star, Tom Cruise in this case, and write this test tape for us. Again, it's not inventing it, it's actually looking at the current application under test and building it in a way that really applies to and tailored to our application. If I want a random movie star on every run, all I need to do is just ask it. It's plain English, very easy, okay? I can say fill out the form as a random famous 90s movie star, and the LLM will understand that it needs to generate a data set. It will come up with its own variables that, with all the details that it needs to fill out this specific form and write the test for us. So the things that work very nicely under the hood here is that you don't need to be a prompting expert to get those nice results. The tool takes care of it. We don't expect the user to be an AI expert. We take care of the model. We take care of the prompting. We make sure to represent the page, validating the results of the LLM, making sure that it's not hallucinating and making things up. And it's all seamless. There's no difference between clicking a button and asking the LLM to fill out the form for you. So to wrap up, my time is up. What we've covered today is that, first of all, we talked about the traditional approach not scaling, the fact that the main bottleneck is the test code, the fact that a lot of the innovation that we see in demos today and the excitement only leads to generating more test code, which doesn't really solve the problem, and only making it reinforces it. We talked about the fact that LLMs are not reliable enough to trust them blindly to run our tests. And in order to succeed with automation at scale, we need a solution that is inclusive and allows all testers to participate, but it also needs to be fast and reliable. And I hope that I've shown you that autonomous does deliver on that promise. So thank you very much, and sorry if I'm a minute too late.
Thanks a lot, Adam. We just have you to ask one question of our audience. Whoever gets the question right, first to raise their hand gets the gift card.
Thank you. Okay, so how can autonomous use plain English for writing a test, but still run deterministically and reliably and fast as a programming language? What's the trick? That's not exactly it. For the plain English part?
Deterministic LLM model.
Right, exactly. A deterministic model. Thank you very much. I just give it to him?
Yeah, of course.
Okay.
Go for it, mate.
Well done. Thank you.
Congratulations. All right, everyone. Enjoy lunch. Please, don't forget to do the postcard game and all the little things out in the foyer. Have some fun with it. That was pretty cool, Adam. A lot of pretty amazing stuff there, particularly the integration with artificial intelligence. Pretty cool. It's amazing how far the tools have come the last few years. I think AI has sort of accelerated that a little bit.
Yeah, and I can add that it's a lot of fun building those tools. The team is having really great time.
Damn straight. And we see that in your passion, mate. Good job.
Awesome. Thank you.
Thanks again, Adam.